Hey guys, hello everyone. So today we are going to try to, we are going to solve the number of islands questions from LeetCode. It is one of the most asked interview question for Amazon interview, and if we see, it's a lot favorite for most of the companies. So yeah, let's start the timer for 15 minutes. If we are not able to do it in 8 to 10 minutes or so, we will see the solution. So here we go. Given an mn2n 2D binary grid which represents a map of ones and zeros, ones being land and zeros being water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. Okay, horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So to be honest with you, I've solved this problem a lot of time. So let's see um, if we can do it. So my first intuition is to go to DFS. So this is 4 into 5, right? This grid, I'll make a grid here. So we have a walkthrough. If you can see it on my screen, 1, 1, 1, 1, 1, 1, 1. Then 0 0 0 1 1 1 1 0 0, and the rest is filled out with water. So if you can see here, this is all land. This part is all land which is covered with which I'm identifying it with the color green. And yeah, let's take blue, and this is all water, or I'm talking the other way around. Oh, 0 is water, and okay, so yeah, this is all water. 0 is water, sorry about that. And this is all land. This is all land. Okay, so this is all. So here we can see that we have just one land, and the rest is all water because this all ones are connected to each other, and there is no separation between the land. If suppose, let's say, if we would have here zero instead of one, then the land would have divided into two parts, namely this and this guy, and the water area would have increased. So yeah, what we'll do is, yeah, so we have to run a for loop through all the nodes. Like yeah, we have to uh, run the uh, run the for loop through the entire matrix, and then what we have to find is we have to find a one, and we have to find its all horizontal and vertical neighbors, which are one. And as soon as we come out of the loop, we can update the value. We will, when visiting a particular one, will change it to some other value um, for us to identify that that node has already been visited. So yeah, let's not waste a lot of time in this. Then probably we'll need a for loop let I is equal to 0, I is less than grid dot length I plus plus, and then we have to take let j is equal to 0, j is less than grid of 0 dot length, and j plus plus. Once we've got this, then we have to check if current grid of I and j is equal to 1. If it is 1, then we have to run a DFS on that I and j, and then we have to also send a grid to it. And finally, yeah, so one more thing, we can have grid equals to sorry, number of islands equals to 0, and as soon as this guy comes out, we can update this number of islands plus plus, and in the end we can simply return number of islands. So one question to clarify is that, so edge case, so I'll come to that question later on, but um, grid will check if grid dot length is not there, then we'll simply return 0. We are anyways going to return 0, right? Because this won't loop through anything and it will eventually return 0. So that edge case is not mandatory. So let's create a function dfs and dfs I. Let's call it a row column and the grid. And if r is less than 0, so these are edge cases, boundary edges. So r is less than the boundary, then r is greater than or equal to grid dot length, or c is less than 0, or c is greater than equal to grid of 0 dot length, or we have to specify a special character uh, for a grid value that we are going to assign. We'll see if it is equal to if it is not equal to 1, then I guess we can use the reverse order of it, so that, yeah, if it is not equal to 1, only if it is 1, then we are interested to see that current nodes for the neighbors. Return, yeah, we just want to return. And then here, once we have identified the uh, the graph node, which is 1, then we can change it to, let's say, x. Yeah, okay. So yeah, and then probably, okay, yeah. So we have to go to the top and left, right. So DFS, first will go r plus 1 to r plus 1 c and pass on the grid. DFS r minus 1 will put off with this. And then we'll pass the grid. DFS r c plus 1 c grid, then DFS c -1. Okay, sorry. R will be as is. My bad. And then we'll send the grid here. Okay, cool. So we have this in place. So last time we made this mistake when copy pasted this, but this time it's all okay. And it should give us 1 for this. And as you can see, this guy should give us 1 1 1 0 0. This is 1 and 3. Okay, let's run this. Oh, okay. So in case it's calling DFS, then we are also passing the grid. The grid reference changes, or if it is changing, then we have to move this function. This part confuses me sometimes. If I'm passing the reference, I guess we are passing the reference of grid, so it should be updating the grid to X. So here we don't have to anymore pass the grid. We have to just worry about changing the parameters of this guy. Yeah, so we have this, we are calling DFS, then eventually we are returning. Okay, so number of islands it's turning out to be, it's catching all the ones. If it is not equal to 1, if it is equal to 0 or grid of R and C equal to X, at that point we are not interested. That's what I meant. So we are doing this DFS for all of them. Then it should be going here, this converting this guy to X. So my algorithm, if I show it to you in the whiteboard, 1 1 1. So how many ones were there? Okay, it was like this: 1 1 1 and 0, then 1 1 1 and 0, then there was a 1 0 0 0, then 1 and 1 0 0 0 0, 3 3. Yeah. No. So this is the thing, right? So on the first iteration, we'll be getting 1 here itself. See, 0 4 0 1 2 3. On 0 0, we'll get the first one, which will be converting it to X, and then we'll search the bottom one, the bottom, then this guy will turn to x because it's 1. Then will this guy will run this x, and as soon as it sees a 0, it returns. Then it goes here, and this goes here, returns this, returns. And this goes here, this direction, it returns back. So this goes here, and then x. Then this will also try to go. Sorry. Um, the timer is over. So yeah. Sorry, my bad. So x, this so this will also turn x, and then yeah, it will go here, here, here. Everything will turn out to be x, and they will return, and eventually just and once it's traversing through the um, entire grid, then it won't be finding anything else because everything is converted to x, or if it's 0. Equal to, really? Just change the equal to sign here. Okay, no worries. So yeah, that's a good lesson. Always put triple equal to sign because it checks for the type and the value to be same. Double equal to has type coercion. That, I guess that's what it called. It tries to change the value. So we'll submit this, and I had this out. So let's take this out. Let's undo everything, whatever the code we had. It should have worked nicely with just adding those two equal to sign and then run it with three equal to sign. Okay, yeah, that is the problem. Okay, so let's see if console log grid here. Let's see if the grid value changes. No, it's not changing at all. So even if we are passing the grid, so control Y, control Y doesn't change anything. So yeah, let's jump back to the earlier implementation where we had this guy inside here, and we are not passing grid anymore. It has global access. Okay, so once it has the global access, then we'll change. I just ran the algorithm and it, okay, yeah. Triple equal to again here with, okay, yeah. But I have kept double equal to, okay. Oh yeah, again I've kept single equal to, but yeah, you get the idea, right? So it's 97%. Okay, cool. Um, so yeah, that's it. So not, sorry, I forgot to explain the time complexity. So time complexity would be we are traversing through all the nodes, right? So it would be m into n, and if yeah, so space complexity would be also m into n, even if we are having a visited, if this is not a good practice. So the follow-up question I was talking about, the follow-up question would be not to modify the value of the matrix. So instead of that, what you can do is you can create um, a what a visited matrix, and then you can have true key and false value, true and false values filled in them as and when you're visiting the grid. So editorial solution, if we go there and see the time complexity, yeah, it's the same thing. And uh, DFS, how they are implementing it. Let's see. See, they are also sending out the grid, and then here, okay, they are also doing the same thing. Why my grid is not converting? And solutions, let's go to solutions and see JavaScript. Okay, there is also my solution. Yeah, see, I've sent a grid. I've converted it to X. Last time also I converted. I did the same code last time. Okay, cool. Yeah, that will work. This code will also work. So, okay, we discussed the time complexity and was able to come up with a solution. Let's see if there is some DFS is accepted one, and there is also PFS. So I guess in BFS you will traverse the node, then it will be one nonce of Ireland plus plus, then RNC change it, you'll put Q neighbors dot push RC. Okay, you can also do it union and disjoint. It's been a while. I haven't touched it. I need to revise this. But I'm surprised this can be done with union find too. Okay, but yeah, none of them increases the time complexity of this. So DFS should do just fine. Simply attempt at understanding. Okay, cool. Okay, thanks for watching. Catch you on the next stream. I hope my explanation in the interview at least gets better. I don't know how should I should be focusing more on asking questions. Like as soon as I read question, ask questions like can we change the value? Do you want a visited? Uh, can we change the value of the grid to identify, or do you want to have some other visited array to manage which part of the array we visited? So I guess these questions we should be asking next time. But yeah, this is good. Thanks. Thanks for watching.